Hey guys, good morning.
Morning.
Morning. Thanks. All right, guys, we are going to start soon. Give me one more second. Let me set up the server and we can start. All right, guys, let's start and let me share my screen. Are you able to see my screen now?
Yes, we're looking at the PowerPoint page where you can see all the slides and then the next slide and then the notes.
Oh,
You can
that's
see
not
presenter
correct.
view, basically.
Yes. Sorry, 1 second. I'm really bad at using any product with a GUI. So give me a second. Let me reset.
I feel that definitely.
All right. Hopefully this work. Does it work? It should work.
Looks good.
Awesome. Cool. Hey guys, long time no see. We haven't been seeing each other since 2 weeks. And now we're gathered together again and work on fun challenges from software security, CSE545. So I know that you guys are working hard on the assignment, and this is nice. I saw that. It's great. So first of all, again, it's about an announcement. I don't have very special things that I would like to announce. Other than that, assignment 1 and 2 grade are released. You might already notice that if you like subscribe to Canvas notification. If not, you can just go to Canvas and check your score. And please do check your score. Make sure that your score is aligned with your expectation. I do come across some issues from students who let me know that their score has problem, and it turns out this is because of like not updating your grace period, or it's because of the script has problem, because we automatically grade it and sometimes it has bug. Although I don't think that this is the general case. So it should be most of them, they're correct. There might be corner cases. If you do find something wrong with your assignment, let me know. And also, some of you, I know that this is because you didn't update your score in WeChat. So just to be fair, if you don't upgrade your score in WeChat, let me know ASAP, and I will help you to resolve this problem. Because the goal for me is really not to reduce your score. I personally don't care about grades. So I think that everyone's effort should deserve a good grade. Sorry, should deserve a good grade. So definitely let me know if you just miss to update your progress in WeChat, and then I'm gonna give you a grace period, like a very quick, probably like in a couple of hours, and have you to update right now, right away, so that I will be able to regrade your WeChat score. All right, so give me a second, let me mute my Slack. Actually, let me quit it. All right. And as you know, assignment 3 is ongoing, and you guys are making very great progress. The deadline of it, if I remember correctly, that's the end of this month. So you will still have a week or so to finish the assignment. If you haven't started, you really want to start, because if I am gonna work on the assignment right now, and I probably have to work on the assignment like 3 or 4 hours every day if I started right now, and if I want to finish all the assignments. So make sure that you start, if you not start ASAP, so that you will still have enough time to finish this assignment. But still, if you cannot finish it, you can use your grace period. I want to remind you that you still have 3 days as your buffer, and you can file in a grace period request. I have that link before, and I think that it should be somewhere still, probably in my course schedule, or at least you can get the link from our previous slides. It's also online on the schedule. You should be able to get the link. If you cannot find the link, let me know. I can let you know where the link is. So there are some of you have already used the grace period for your second assignment, which is good. You want to take advantage of it. So yeah, no worries, and you're not gonna get any of the score deducted because of your using your grace period. Make sure that you use it in the right way. If you don't need it, I would say try to not use it, and then save it for future assignments, because later on when we talk about heap, I mean, we already start heap, and we will talk more and more about heap, and you will start to realize that actually heap is very different mindset comparing to stack. So you may or may not get used to it. That means that in assignment 4, you may have to cost more time or maybe less time. It really depends on your personal thought, your personal style. But yeah, it's good that you want to play safe and save some buffers for assignment 4, just in case that you cannot finish in time for assignment 4. Especially, it's gonna be Thanksgiving, and you may want to spend a little bit more time with your family and your friends. Okay, so any questions so far? Otherwise, I'm gonna start today's lab. Good. All right, so today's lab, we are gonna work with challenge at the port of AAAA. You should be able to access it right now. Let me check this on my site, but I believe so. it is working. And then the binary is has updated. It's if you look at the course schedule, you will be able to find the binary which called use after free in today's item in October 22nd, 2020. I will copy the link over here again and then paste it on the PowerPoint. And let me make this a little bit smaller so that it will be fit in the line because I'm paranoid to that. Still not aligned? Good. All right, let's work on the challenge. Oh, I saw some of you guys are saying that the binary is 4-4. Let me check my link. Sorry about that. Shoot, hold on. Let me re-upload it. Okay, I'm pretty sure that I'll upload it this time, but it's gonna take some while to get synced up remotely. Let's give it a little second. In the meanwhile, if you don't have libc 2.27, please download the library and make sure that you can run it properly. And then let me post the library in the Slack for now, but it should be updated very quickly later. All right, guys, I uploaded the binary in the general channel of our Slack. You can get a copy of the library over there for now. And I'll let you know when the course website's binary is ready. The binary is also available online, the course website now. You can download from over there. Hey guys, we got first blood. So one of you has already successfully logged your self-participation in the server. And also, I'd like to release the source code of the service right now. If you're still reverse engineering and you still don't know what to do with the code, you can use your source code. And then I'm going to copy paste the link of the source code in the slides as well. And then you can download the source code and try to get the vulnerability and exploit from the source code. All right, guys, the source code is also on the course website now. I put the link on the slides. And also, we are gonna have about 5 more minutes to play with the challenge. After that, I'm gonna start and we're gonna work on the challenge together. All right, guys, let's start to work on this challenge together. Let me resume my share. Hold on. Oh, actually, let me initiate a new share. You should be able to see my terminal right now. Let me know if you don't. Okay, so this challenge, the left-hand side is the source code. But before I go over the source code, can anyone tell me that while you're doing reverse engineering or while you are reading the source code, what do you observe from the source code? What does this program do? Anyone like to share the thought? No? Okay. But have you have any idea that this, have you tried to interact with the server? Have you tried to interact with the service? Oh, nice. In our chat, Robert said that it allocates and deallocates memory on the heap. Yes, you're right. And by the way, Robert, you're the first blood. Congratulations. So yeah, so this particular program, it has a very nice interface. I wouldn't say it's nice, actually. Let me rephrase that. It's not really nice. It's sketchy. But like from the nice thing is that from this program, you basically be able to see most of the content by looking at the menu, by also running it. If you run it offline on your own like local machine, you'll be able to see that it asks you to choose from the following menu, choose the item, and you could exit the service, you can exit the program, you can malloc, you can free, and then you can edit the allocated chunk. You can also just like list all the pointers. So if you have checked the video that I posted in this week, you should be able to realize that this particular source, this particular service has a use after free vulnerability. So this means that you will be able to edit a chunk if you free it. All right, so now let's try this. And then what I'm going to do is I'm going to use GDB to run with the program. And then I'm going to run. Now, let me just like allocate something, a random thing. I'll just do 8. Okay, and then right now I'm going to use Control-C to interrupt the execution, but it will still stay inside GDB. And then I'm going to use this in pound the bag. I know that Jeff, they may have a different command, but you probably want to figure out the equivalent command by yourself. For now, I'm going to use pound the bag. And then we'll be able to see the heap layout. So this is this heap chunks. So right now we see that there are some chunks in blue, some chunks in purple, and then some chunks like in green, some other small part in green, and also small part in yellow. So those parts that are in blue, they're called T-cache. And if you have checked the video that I posted, you know the structure of T-cache. You know that, you should be able to know that this represents the size of this entire chunk of T-cache. And in the T-cache, it composed of 2 parts. One is the count. I'm gonna just put it over. Oh, actually, it's a little bit too narrow. Hold on. Okay, so like part of it, this might not be correct, but like part of it is count. It may not really end from here. I'm just like draw a random stop, but I just want to show you on the high level that part is count and part is the stored entry, which is also something that we called a bin. So this part of the T cache is going to store the information of a free chunk. This is exactly why it's called cache. Just like, you know, you memory, you have cache. T cache is a cache stored for each thread. So in this case, once a chunk is freed, it will just keep here, stored here temporarily, so that it will be used again by the same thread in the future. Okay, so next is this part. This is the purple part, and this is actually the allocated chunk. That we just use, you know, the malloc option. So this is a very nice command. Besides that, you can also use, I use heap a lot because heap will give you all the chunk information. So here it tells you that the allocated chunk, the first one is actually T cache. And then the second one, this is the chunk, the purple one that we just allocated. And this is the rest of the chunk. Okay, and then let me clear. And then now what we're going to do is, oh, and by the way, another command that use a lot is beans, which will show all the beans, you know, currently in the in the process. Okay, so next what I'm going to do is I'm going to continue the program. And then use L, I can check the manual again, and as well as the current allocated pointer with their index, the information. And the next is that I'm gonna try to free it. Okay, I'm gonna just free this first one. So use F followed by the index, which is 0 in this case, because it's showing over here. Okay. And then let me now do Control C again. And let's check this. So now you'll see that we have more information over here. And actually, if you look at beans, you will see that right now we have a Tcache item is a chunk that I put into Tcache bin. This item has the address of 603260. So it is here. Right. So basically this part, this is the address of the chunk. It points over here. And it refers the chunk that we just freed. And you may wonder that why the chunk is actually starting from here instead of this part. If you check the video, we mentioned about the data structure of the chunk. And the first 8 bytes of the chunk, when it is allocated, represent the size and the flags for each chunk. So this is the metadata of the allocated chunk. The actual data of the chunk will start from here, 603260. And then for Tcache beans, when a chunk is freed, it will store the location of where the data start instead of the metadata. Notice that this will be different when you look at the other beans. But for now, since we're only focusing on Tcache beans, it's fine for us just to consider this as the start of the chunk for those for your data. Okay. So now we have a brief idea of how free works. and also how a chunk is allocated and how a chunk is freed, putting into Tcache bin. Now let's talk about the use after free vulnerability. So what is a use after free? I think that many of you may have heard about this before, right? So that means that you have a pointer and then you free the pointer, but then later on you use the pointer again. It really seems okay, in a sense that as long as your data is there, you can still just use it, right? But it's very dangerous because when you free a chunk, your chunk will actually start to store more information, and those information will involve metadata. So in fact, if I run this starting from a start, and then if I gonna do malloc 2 chunks instead of 1 at this point, so I'm gonna do malloc 8 again, malloc another 8 again, and then now I'm gonna free both, free 1 and free 0, right? So now I've already allocated 2 chunks, and then I also already freed the 2 chunks. And now let's take a look at the bins again. Because these 2 chunks, they are in the same size, and also they're in the size of hex 20, we're gonna put in the Tcache bins with the size of hex 20. Also, if you look at this, you find that this is the first Tcache entry. The first free chunk in the Tcache bin, in the Tcache entry. And then this is the second. Let me make this a little bit wider so that you will be able to see. Hold on. Sorry, I escaped from the window. Okay, now I'm back. So yeah, so you see that this is the first one. Let me look at bins again. We can compare and see this together. So this is the first item, which is this 3280. And then the second item is 3260. But if you look at Tcache, it only records the information of the first item. If you scroll up, you will be able to see the item's information over here. So the way that Tcache bin works and tracks the rest of the free chunks within the same size is through the metadata that's stored in the chunk in the list. So here in 603.280, it stores the address of the next chunk. So this is like a chain, a list that they really link each other together using this part of the information, which is stored in the chunk. So use after free happens. Essentially, this is because when a chunk is freed, this part, which is originally used for storing the actual data, will be reused, recycled to store the metadata of the heap. So if you are going to add a free chunk, you may just touch this part. In that way, you will be able to change this location. You can change this to some value that you like. And then if you look at the bins, then the bins will not point to this place because you will overwrite it, and the actual Tcache bin will point to somewhere else. And for attacker, this is nice because attacker can manipulate the address over here stored in this particular location if it's gonna reuse this chunk after it's freed, and then it can point it to another place that stores sensitive information so that when the chunk is allocated again, it will go to that particular allocated location and write the information over there. So in this case, attackers will be able to get an arbitrary write. So recall last time we talked about arbitrary write means that you will be able to write to an arbitrary address with an arbitrary value, right? So it's like, I'll put it here, arbitrary address with a value. So that means that if you have, a freed chunk 1, which point to a freed chunk 2. So you can add free chunk 1. Remember, you're not going to add it free chunk 2. You need to add it this. So this is the so-called use after free. You want to add a free chunk 1 so that this time free chunk 1 will point to adder. Right? So this adder is this adder. After you make that happen, then you're going to use Malloc to first Malloc the first one. After the first Malloc, this free chunk will be returned. And then next, we're going to do another free Malloc. And then in this case, our added address will be returned. So if you have a p equal to Malloc, so that means that you can get the pointer. Now next, what we could do is just put p, or say start p, with the value. So you see, this is very fun. Like you use after free, you can make it go to the address that you want, and also you can put the value that you want for this address. It's all connected. Okay, so the only thing that you need to be careful while you are working on a challenge like such is that you really want to make sure that this entire process, like those that I draw over here, you have that in your mind. Sometimes I myself use scratch paper. Like I need to really write this down or like draw this in order to make sure that every process is correct. Every step is accurate. Like this part, Malloc twice, is something that I miss. Sometimes I can't remember this very clearly, so that I only allocate for once, and then the complete layout of the heap will just go wrong. So really make sure that when you write a program like this, when you write an exploit, you have this clear mind. I really encourage you, to first of all think about the list and interact with the service first to play it, to sense the heap change, and then come up with a graph, come up with the step 1, 2, 3, and later on map those steps with the actual implementation of the exploit. Okay, so now let's gonna write the exploit together. Since we already have this in our mind, writing the exploit should not be very hard.
Professor, I have a
Yes.
question. How does the Tcache bins keep track of the size of chunks? For example, here we have a 32 byte bin in the first one,
Yes.
right?
Mm-hmm.
So how do you keep track of, how does the Tcache keep
Yes.
track of that?
Yes, this is a nice question. There are two parts. One is that how Tcache bin keeps tracking the size of the chunk, right? And the other part is how Tcache bins track the counts, like meaning the
Yeah.
number of items in the in this bin. So here, if you look at Tcache, do you see the digit 2 over here?
Yeah.
Right. So this is the part. This is the element in the Tcache structure that it stores those count for the for each bin. So
Okay.
basically, Tcache element, Tcache on the higher level, Tcache is fixed in the set in the in terms of size. If you look at
Yeah.
yeah,
Okay.
good. So you know that like it's hex 20, it's a bin, and then hex 30, another bin, etc. And then for each bin, it has this to locate the count, and then it has this to to track the first element in the bin, first chunk. And then
Oh,
you're making, yeah, go ahead.
So is it fixed? The first T cache bin is supposed to be a hex
Mhm.
20, next one hex 30, and so on.
Yes. So
Okay.
this is the first. Yeah, this is, well, it's not really fixed, or say it's fixed in the sense of while you're freeing it, and then, well, let me rephrase that. Actually, it's not fixed. So that means that if, so suppose that you have a chunk and then you free it, and then this chunk will be considered as the first chunk. So it will be the address of it put over here. But next, if we're gonna then followed by that, if we're gonna free another chunk, then what Tcache will do is that this chunk that's already put over here will be moved as the second one. So the new one is like a stack, right? So it's like you
Okay.
first in, last out. So you put the new chunk here,
Yeah. I
and
am aware
then,
of that. Yeah.
yeah, and then you change the address here. So this address will be changing.
The newest chunk. So,
Yes, exactly.
so the sizes are. I'm sorry, and not yet understood for me. Still, like how do you how does the Tcache bin know that the first chunk is first list of chunks are of size uh, hex 20, and the next one would be something like a hex 40 or a hex 50?
Yeah,
Is
this
it
is a
just
good
dependent
question.
on what we had uh, uh, set earlier and then freed?
Not exactly. This is because Tcache hard coded it. This is a very good question. So this
Okay.
is because Tcache, in Tcache, it has a very, like, a hard coded that the first bin is always hex 20 in the size of hex 20. The second's always in the size of hex 30, and then hex 40.
Okay.
And then, and to actually, I forget the actual value, but like you can check from here.
64 entries. So
Yes, yes, exactly. They have 64 entries. I can't calculate the math very quickly, but you know, like they're
I
like the
understand.
entire is 64.
Yeah. Okay, so it's hard coded, as in the bins are
Yes,
hard coded. Okay.
exactly.
Okay. Cool. Thanks.
Awesome. Those are very nice questions. Do you have any more questions?
No, I understood this part. Thanks.
Good, thanks. Okay, now let's start to program. I'm gonna exit. Actually, let me keep this part just in case that we need to dynamically interact this to get some information. I'm gonna quit the source code, and then let's, given a limit of another amount of time, I am going to use a template that I wrote before. But the template should be very easy for you to reproduce. Let me just open this, and then actually, let me copy it, and then we can start from over there. Okay. Okay, so first I'm gonna show you the template, like those utility functions that I wrote. If you remember, when you run the program, you will have this menu that you need to interact with, right? And then, like if you're doing Malloc, you need to put it with the size. And after that, you will get the manual again. So the first thing that I do is to write those small snippets that will allow me to interact with the server. So you see over here, those are what I'm doing. I have each of the command associated with each of the small function snippet. So like the first one is Malloc. What it does is it's gonna send a line to the interacted process. I'm doing this, it's like and with the size, And then I'm gonna receive the output until I solve this part, which is the end of the menu. And the nice thing is that if you have this, you don't need to worry about the, how to interact with the server. What you only need to worry about is the entire like exploit process, which I really like. So when you write your own exploit, I highly encourage you to have those snippet first and then reuse this later. And similarly, you have free, you have edit and exit, you have all those, those that are ready for you to use. And then you can then just think about the attack process. And then you're going to use those smart part of the code to execute the entire attack process. And then this is the main function. So what it does is very simple. It first is going to check that if this program that I'm going to run, if this one contains the argument of GDB. So this means that if I am going to have, say, like attack demo, and then followed by GDB, this argument will capture this, and then it will debug this binary. Also, if I have remote, then it will use this to connect to the, the remote server and interact. Otherwise, if I don't put any argument, it will just run this locally, plainly. All right, so that's the main. And then in the main, we're gonna launch the attack after we have this, process. And the launch attack is this part that we're gonna work on together. So given the limit of a time, I am actually not going to, well, actually, let me just spend a little bit more time to explain this. We're not going to write this line by line. And actually, as you see, the lines are very short. Launch attack, this part, there's not too much code. Let's just go through the process. And then you can use this, like this steps, to map with your code, your function, your utility function that you wrote. So as we remember, the first part that we need to do is to build up this free chunk. We also need to set up the free chunk in the Tcache bin. So we want to have something like in the Tcache bin. You can choose whatever bin. It doesn't have to be hex 20, but you want to make sure that in this bin, you have a chunk 1 and chunk 2. You have to have 2 chunks because the metadata will only be displayed once you have 2 chunks. So make sure that you have 2 free chunks. And in order to do that, you need to do malloc for twice, right? And then free for twice. So this comes to the first step. We malloc and then we free so that there's chunking Tcache. And actually for this particular attack, what I'm doing is I'm only using 1 chunk. So in this case, if you have only 1 chunk, although the metadata is showing 0000, you can change that 000 to our arbitrary address. So even though there is actually 1 chunk we freed, when Tcache looks at that, Tcache will consider this as multiple chunks. So here we're doing is we malloc and then we free. So in the step 1, actually we do 1, which also works. And then from there, the second part is that we are going to add the free chunk in Tcache bin. So the question is, what address that we want to use? Now let's brainstorm. If you already have an arbitrary write, you can write to any address with any value. And also you know that there is a win function in your program. What you could do. So what you could do is that you want to override a function pointer. replace that with the win function. And then you want to call that function so that when the function is called, it will actually go to the win function, right? So the question is what function that you would like to use. If you look at the source code, or actually if you look at the interaction over here, you see there are many functions that we can select. We can use malloc, we can use free, edit, or list, whichever one that you like. For me, I just use malloc. So that means that after I managed to overwrite the got table of malloc, which is the place that stores the information, the function pointer of malloc, right? So I want to replace that to win, and then I am execute. Then I'm gonna execute m again, so that I am gonna malloc it. Okay, so this is gonna be the last step, right? So that's the last step, which is response to here, interactive. Now we need to sort out something in the middle. So we need to make sure that we are able to overwrite the chunks information, the metadata, so that it will point to the address of malloc. So where is the address of a malloc? We can use e.got. So e comes from the elf. If you look at pawn tools above, the code that I write. So you can just use elf binary, having e as the elf object, and then you can access the symbol information using the elf object by pawnlib. But if you don't have pawnlib, or say you don't want to use this, or say if the binary is stripped, you can still get this information by reverse engineering. Okay, and then the next is that after I make the pointer, I'm gonna add this free pointer, right? So this is the free chunk. I wanna add that with the value of pointer. And then, as we mentioned, we need to do 2 times of malloc. The first time is get the free chunk, and then the second time is gonna go to the actual victim pointer. And then we add it again with the value that we want, which is the function, the address of function win. You can also get that from symbols, since the binary that I gave you is not stripped. You can also get this by reverse engineering. And then in the end, you're gonna do malloc again. And here I'm gonna use interactive so that you need to malloc by yourself, because also I wanna check if my malloc is correct. Okay, so let me run this on my site. Hopefully this works. Okay, it's attack demo.py. Now I'm in the interactive mode. I can use list. I can check the listed pointers and also the manual again. And then here I'm gonna just randomly malloc something. Like the argument doesn't matter because it will go to win function anyway. And then win function doesn't care about the argument. Okay, now you are gonna you'll be asked what your ASU right. You're gonna put your ASU right over there, and then you're good to go. Cool. That's pretty much for today's lab. Now I'm gonna stop recording, and then you're welcome to stay here and ask me questions until 11:30. After that, we will start the TA's office hour, and you can come to TA's and ask them questions.